Dear students, let us discuss fourth lab program, that is shift reduce parsing technique. Shift reduce parsing is a popular method of bottom up parsing. In the sense, parser is constructed from leaves towards root. That is, when a string is given, that string must be able to reduce to the start symbol. Here in this example, grammar is given as E gives E plus T or T gives T star F or F gives ID or parenthesized E. And the sentence means the string given is ID plus ID star ID. Here, we know the precedence rules of mathematics, isn't it? So, whenever string is given like this without any parenthesis, this ID star ID must be reduced first. I mean, it is evaluated first, and then it is going to be added to ID. So, we must take care about this also. Here, let me explain how this works. Means this is our expected output. Means which is having three columns like this: stack, input and action. Uh, First we have to enter the input string, that is ID plus ID star ID. Initially let us assume stack as just a dollar. Okay, dollar means bottom of the stack. Input is ID plus ID star ID, no? So first, always shift reduce parser always try to push the input or shift the input onto the stack. And one more thing, shift reduce parser is having four actions. One is shift, another one is reduce, then accept or error. Out of these four actions, first action is always shift. It has to be pushed onto the stack. So first input is ID. ID is shifted onto the stack. So our first step is stack contains ID. Action is shift ID. After that, what happens is in shift reduce parser, it always try to reduce the contents of the stack to its RHS. Since ID matches with this production, that is F gives ID, there is a production. ID is reduced by F. So we need next action as reduce. So write the action as reduce and ID is reduced by F. And one more, okay, later what happens, F can be reduced to, see, using this production, T gives T star F or F. So F is reduced to T. Later T can be reduced to E. After that, E is already our start symbol, so it cannot be reduced further. So what happens next? The parser will try to shift the next symbol onto the stack, which is the next symbol, that is plus. So plus is shifted onto the stack like this. So action is shift symbols. Okay, then also whenever plus is shifted onto the stack, we have E plus on the stack, right? Whether is there any production to reduce E plus to its left hand side? We have E plus T, but we don't have E plus. So E plus cannot be reduced to anything. So parser will try to push the next input symbol onto the stack. So next input symbol is ID. So shift ID onto the stack. Now stack is E plus ID. Now what happens? Top of the stack contains ID. Like our previous step, this ID can be reduced to F. Just observe here, ID can be reduced to F, so action is reduced. Then F can be reduced to T. Okay, here very important thing happens. Even though this T can be reduced to E using this one, okay, like our previous step. See here, in our previous step, T is reduced to E, right now here T is reduced to E, but now we don't want that T to be reduced by E. Why? Because there is no right hand side to reduce left hand side, that is E plus E. If we have a production like this E plus E, we cannot reduce right hand side to left hand side. There is no production like E plus E, so we need just E plus T. So in that particular case, in implementation, we have to check whenever stack contains E plus T and there is some remaining input like star. Okay, we are implementing the program for this only, id plus id star id. This is our concern. So directly we can check like this. Whenever stack contains E plus T and input is star, we have to shift the input star onto the stack like this. Okay, this is very important point. I will show you when I explain the program. Whenever stack contains E plus T and the input contains star like this step action is to this step action is to shift star onto the stack. So star has been shifted over here. Then there is no production to reduce E plus T star onto left hand side. So ID has been shifted onto the stack like this. Then what happens? This ID can be reduced by F like previous case. ID is F. Okay. Now also whenever stack contains this and input is this. Okay. Observe clearly. T star F. Even though there is a possibility to reduce F by T, okay, are you following? F by T, there is an option, but this F will not be reduced by T because we have to compute this ID star ID. So entire T star F must be reduced by T using this one. T star F will be reduced by T. So T star F is reduced by T in the next step. Observe here, T star F is reduced by T. So we got the next step, E plus T, and finally E plus T will be reduced by T, reduced by E. So this is our last configuration. Stack contains start symbol E, input is dollar, and okay, action is reduce. So whenever we have the combination like this, stack is start symbol and input is dollar. Dollar means we reached the end of the statement. Then the string can be accepted. Okay, here there then the next step you can write accept, or here itself you can mention success. This is how shift reduce parser work for the example id plus id star id using this grammar. This grammar in the sense E gives E plus T or T, T gives T star F or F gives parenthesized E or ID. Now, how to implement this? These are all the variables we require: Z, then I, J and C. C, observe the comment over here. C for the length of the string, I for stack, J for input and Z for check function. Check function in the sense there is a user defined function check here. This is a declaration. Check is used to check which action to take, that is whether to shift the symbol or whether to reduce. Now these are all the single dimensional arrays. A for input, AC for shift action, AC for reduce action, and ACT for shift action, and STK for stack. Okay, A for input, AC for reduce, STK for stack, and ACT for shift action. For single dimensional array we are making use of. Main function, first display the grammar is, okay, it gives E plus T etc. Then enter the input string. Whenever string is read, find out the length by using string length function, which is stored in variable C. C contains length of the string. Next we have to write one action, right? For initially we have to shift the first input symbol onto the stack. So write string copy. Using string copy function we can add shift string to ACT array. ACT for shift. So ACT array contains shift. Then print the require output format. We need stack, then input, then action. Okay, it is a our format, how to print the output on the console. Next we just one line. After that use one for loop. For I is equal to 0, I for stack and J for input. So stack means we have display from the beginning itself. So I is equal to 0. J is less than C. Number of symbols which are present in the input format. So J is less than C. C, it is C. C holds the number of symbols present in the input. Increment I as well as J. Then check whether input contains id. See, please remember we are implementing this program for id plus id star id. Okay, that is our concern. It will not work as general program. Okay, so I just check whether if the input is id. So array of j is I, and next symbol is d, id. Okay, if it is the input, then shift id to the stack by using this stack of I plus 1. Okay, like that. Then last stack of I plus 2 is null character. Okay, stack contains id now. Then why do we require these two statements? That is making null. Array of j is equal to null and j is plus 1 is equal to null. Means just meaning is deleting id from the input, but actually we are not deleting. We are just making that position null. Got it? No? Okay. Now id is already considered. So see, I will show once if you want. Where is our format? Okay, here. Okay, after considering first id which has been shifted onto the stack, then we have to consider next input as plus id star id. So these two positions, I and d positions, are made as null now. Okay, then that function is over now. Now display the first line. How? We require stack content to be displayed, we require input to be displayed, as well as we require that shift, this one also we need. So display the first line in the expected output. Then call check function. Check function is called by whether to shift or reduce with the contents of the stack. What action to be taken next? For that purpose, call check function. Else, okay, let me continue this main function first itself. Else, if that is, it is not the case, means some other symbols if we have, what to do? Directly they are pushed onto the stack. Okay, if the first symbol is id, then it has to be shifted onto the stack. Otherwise, just if it is not id, directly push it onto the stack. A of j is copied onto the stack. J plus I plus 1 is null, means we are shifting the symbols like input like plus and star. Okay, got it now? In the input, we have id plus id star id. Only that's it. So other than id, we have only plus and star. So those plus and star will be pushed onto the stack directly. For that purpose, this else part is written. Okay, got it? I think it is fine. Okay, for shifting, we have either ID or plus and star in the input. So if it is ID, it is pushed by using this function. If this is ID, check for the input ID, then push like this. Otherwise means we have only plus and star like this. Okay, so plus and star are pushed using this function. Then also call check function. So this is the end of for loop. Okay, after this for loop is incremented, both stack and input array indexes are incremented by 1. And initially, finally we have to check whether the stack contains E at the end of the input. So at the end of the input, if stack holds E, what is E? E is our start symbol. So compare string, using string comparison function, we can do this. Stack and E, if the return value is 0, I think you know the return value of string comparison. On success, it will return 0. Success means stack and E both are equal. In that case, what to do? Printf success, otherwise error. Okay, this is the main function. How then heart of this program lies in check function. How to check, how to decide which action to be taken. Okay, let us go for that. Check function. check function for reduce action. Shift action either ID or plus or minus. Okay, now reduce action. How to consider reduce action? First string copy AC comma reduce. As we know, AC is for reduce action. So first have the content reduce in AC array. Then if stack, okay, now let us start from the beginning. I mean, ID is already shifted. We are there in that particular point now. Uh, Stack holds ID. If stack holds ID, then what to do? That ID, okay, I mean that ID is a single input, no? So um, consider like this only. Stack of Z is I, and next in the next position we have ID. That case ID is reduced by F. Okay, next position is made as null. Then print the contents, that is stack content. A is for input array and AC for reduce action. J++, move the input pointer to skip D of ID and point to the next input. Okay, you are following, right? ID, in ID we have two symbols. So actually input pointer points to that next D. So we have to skip that D of ID and point to the next symbol. Therefore, J++ is needed. Then what next? This is for ID. I mean ID is reduced to F now. Next, that F has to be reduced to T. Okay. See here, if the stack holds F, that has to be reduced to T. In between, we also check if the stack holds T star F. T star F means if the stack contains T star F, then that T star F must be reduced to T. Okay, then print stack input and AC array. Okay, later. As I explained you earlier, there are some very important points where we have to check. E plus T star, no? There is no function to reduce E plus T star. So we have to skip this one. Means next input ID has to be considered. For that purpose, if stack contains E plus T and stack of Z plus 3 means next input. Next stack contains is star, okay, E plus T and then star, then break, just skip. Stack content has to be skipped. And one more chance, if stack is E plus T and input is star, then also we have to skip. That means this T will not be reduced by E. Okay, if stack holds E plus T and the input is star, then break, in the sense T will not be reduced by E. We have to consider next input star. These are the very important points we have to check. Else, one more case, stack is E and stack is E plus T, then E plus T has to be reduced by E. Okay, for E plus T there are different combinations. Stack contains E plus T followed by star, one case, or stack is E plus T and input is star. In both the cases we have to skip the stack content. Otherwise, in last option, if a stack is E plus T, then it has to be reduced to E. Other than these two, it has to be reduced by E. Then print. Then last case, that is when it has to be reduced by E. If stack is T and input is star, we have to break. Else if stack contains star, then we have to reduce it to E. Finally, display. This is about shift reduce parsing using the grammar E gives E plus T or T gives T star F or F gives parenthesized E or ID. And students, just I explained in brief about this. We have to trace the program by yourself, then only you can easily understand. Thank you.